So solving rational equations is the name of the game in this section. So you're going to want to solve equations with fractions in them, but not just numerical fractions, rational expressions, right? So we're going to explore how to solve those kinds of equations today. That's the title, that's the goal of the section. Here we go. In this first example, we're asked to solve in part A, 3/5 plus 2/3 equals x divided by 9. I claim you guys already know how to solve this. But it's technically a rational equation, right? It has fractions in it. It's a rational equation. I suppose lots of equations could be considered rational equations if you think of a fraction as anything over 1. In the past, how did you solve an equation like this? You could get a least common denominator, but is there another way to get rid of those fractions? Or by getting rid of those fractions? Couldn't you multiply through by the LCD? Maybe that's what you meant. I'm not sure. I thought you were thinking of adding these together, which you could do. You could add those together and then get a single fraction on that left side, and then you could cross multiply. That would be a method to use. But the method that's going to work more generally that I'm going to present to you today is we could multiply both sides of that equation by the LCD and get all those denominators to disappear. So let me rewrite the equation. We get 3/5 plus 2/3 equals x over 9. Leave a little space there. And the idea is I want to find the LCD, but I'm not going to use it for adding fractions together. No, I'm not going to do that. So you find the LCD of all the denominators, 5, 3, and 9. What would that be? Do you guys want to, well, you've seen this before, but you want me to remind you of a surefire method for finding LCDs? What you can do is look at prime factorizations. If you look at 5, well, 5 is 5. The prime factorization is 1 times 5, but you don't write down the 1. So that guy's already prime. 3 is already prime. 9 is not quite prime, is it? 9 equals 3 squared. So if you want to find the LCD, what you do is you look at the prime factorizations of each of the denominators involved, and you know that the LCD has to contain one factor, one of each, right? So it has to contain a factor of 5. It has to contain a factor of 3, but wait, it's got to contain a factor of 3 squared also. So what you're going to do to form the LCD is you're going to take the higher power of whatever base you have, in this case 3 squared, and then times 5. And you don't always use that method because sometimes it's obvious, right? What's the LCD of 6 and 3? It's 6, right? But sometimes it's not obvious, and this method works nicely. So you take the product of the higher power of each base, and then 3 squared times 5 is 9 times 5, 45. So we're going to use 45 here, and you could have got that another way. You could have got that just by listing the multiples of 5, 3, and 9, and the first common one would be the least common one. So what we're going to do to clear the fractions then is we're going to multiply through by that 45, right? That's equal to 45. So we're going to multiply the left side by 45. We're going to multiply the right side by 45 as well. Now on the left side, what do we have to do? Why did I put those parentheses in there? What do we need to remember to do? We've got to distribute, so it's going to be 45 times both of those terms. So 45 distributed looks like 45 times 3/5 distributed over addition, so plus 45 times 2/3. And then on the right-hand side, we could just simplify right away. How many times does 9 go into 45? 5 times, so 5x. Everybody with me so far? It's kind of the same trick we used to simplify those complex fractions yesterday, right? Because what are you going to get on this left side? Let me scroll down a little bit. When you can think of it as 45 over 1 over 1 if you want. What's going to be left when the smoke settles, when the dust clears? 5 goes into 45 how many times? Well, 9. And so you get 9 times 3, which is 27. What do you get for 45 times 2/3? So that guy goes into that guy 15 times, and then 15 times 2 is 30. So we've cleared the fractions so that we don't have to deal with them. And I know you guys, a lot of you probably already knew how to do this, right? But we're going to extend this method to maybe rational equations you haven't dealt with in the past. Anyway, finish it up for me. What do you get on the left side when you combine 27 and 30? So we get 57 equals 5x. If you like to work from left to right, so do I. So I'm going to switch it around. 5x equals 57. So what does x equal? Divide both sides by 5. So just 57/5 is a good way to write it. Do you think you can check your answer? You bet. And if you do it with a calculator, it's really easy. If you do it by hand, it's not as easy because you got to deal with the arithmetic. But if you do it with the calculator, it's not hard. And that should check. Part B, we have 5 divided by x minus 1 equals 3 divided by x plus 2. Now, it is true that you could cross multiply here. When you have a single fraction on both sides, cross multiplication works great. But I want to use the more general method at first because it's going to work for ones where you can't cross multiply right away. So what would the LCD be of the x minus 1 and the x plus 2? They don't have any factors in common, right? Don't say x because they don't have x in common. This is x minus 1. It's not x. This is x plus 2. It's not x. They have nothing in common, so how do you find the LCD when there's no common factors? You just multiply everything, right? You multiply both denominators. I did mean x plus 2. Is that why you guys were looking at me funny? Yeah? Okay. And so the idea is you would multiply both sides of the equation by that LCD to clear those denominators, to get rid of the denominators, because we don't like dealing with fractions, right? And on the left-hand side, we get, okay, just x minus 1 times x plus 2. And then on the right-hand side, I'm going to write down the fraction and multiply by the same thing. LCD, x minus 1, x plus 2. And if it's helpful, go ahead and think of, like I did up here, think of these denominators as one object and put them in parentheses to remind you of that. Okay? Any questions on that? So what happens on the left side? What's going to go away? The x minus 1. So we're going to have those guys divide out. And then on the right side, x plus 2. And so does everybody see what we have? We have x plus 2 times 5. What do you get if you distribute that 5? 5x plus 10. And then here we have just 3. That x plus 2 is gone, so we have x minus 1 times 3. What do you get if you distribute that 3? 3x minus 3. And, that's a little messy. So if that's disturbing your eyes, then here's what I recommend. Show this intermediate step of just the x plus 2 times 5 on the left side and just the x minus 1 times 3. If you're, and my eyes don't like that messiness, so if you need to, throw in that step first before the distribution. Okay? But if you're comfortable doing the distribution right away, that's fine. Okay, and now it's just a linear equation, isn't it? So what do you do? Sure, so how do you want to do it? Probably this way, right? And then, let's be brave today and get the constant to the other side. So what would that involve? Undo a plus 10, so minus 10. So we'll do 2 steps in one. So what do we get? So 2x, and then this guy's gone, negative 13? 2x equals negative 13. So what does x equal? Yeah, divide both sides by 2, and you get negative 13 halves. Yeah, I didn't show the work on that one, but we're just dividing both sides by 2. And so there you go. Now, and some of you are thinking cross multiplication is way easier, and you're right, it is. And that's the way I would do this one if I were not trying to show you this method. So check out, what do you get if you cross multiply, just to remind you. I won't do the whole thing, but look, you skip a couple of steps, or at least one step. If you cross multiply, if you set 5 times x plus 2 equal to 3 times x minus 1, or x minus 1 times 3, it doesn't matter, then you skip all this messiness, right? And you land right here. And it is, okay, maybe it's not that much easier, but I think it is easier, right? Now, when does that work? Cross multiplication works when you have a single fraction on both sides. So don't try and cross multiply if you have fractions added together on one or more sides.